Hello, and today I'll be showing you how to utilize the performance monitor to find the most resource intensive parts of your networks. So, how the performance monitor works, or first I should show you if you don't have it here or any other tab, you can create a new type tab, and in here you'll have the performance monitor. So, the way performance monitor works is you click record, and if you compute something, it will record for how long each node takes to cook. So I'll show you an example here. So I'll click on record and I'll click here to compute. I'll come back when that's finished and I'll show you the result. So it's finished. I'll click on stop. So it stops monitoring and we can see that it recorded, or you can also here expand and see the nodes inside and how long did they take. And we can see that the largest or the most resource intensive was the compile end, or this entire compile block here. The reason why we cannot expand this is because compile blocks work in a certain way, like a compiler would work in a script, or if you compile a script, what essentially compiler will do, it will essentially translate the entire script into a more low-level computer language, which the computer understands much better. Because right now, if you, for example, have a script or you're writing something inside of the wrangle, you'll write a code, blah, 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 but the computer itself doesn't understand it. You first need to translate it in a low-level programming language for the computer to be able to process the data. So compile blocks will essentially take this entire thing, because this is a script behind scenes, and it will essentially just translate it into low-level programming language. So Houdini doesn't have the actual information about each node, because this is gathered, or this is computed as a single node or as a single code. So that's the reason why you can't see more detail about compile blocks, but compile blocks are very useful to use. They'll speed up your workflows a lot. So regarding that, you can see how long each of the processes took. And I know in this case, if I want to optimize my network here, the best place to start here would be this compile block here. So either playing with the values inside, maybe upping the voxel size and so on, would be a good way to start, or maybe evaluating if this entire part here is necessary, if it's adding, or usually you're trying to add effects to your geometry or adjusting the geometry, and if this is worth the amount of computation. I showed this because this is a very, very resource intensive part to compare all the other processes in this network. So I have another example here, which is going to be just a pop network. I'll close this here, and it's just a sphere, just creating some velocities using a cross product, nothing special. If I lower this, I'll show you the simulation, like so, nothing special. I'll up the point kind, so we have, so we can see the result, or the difference is much better. And what I'll do, I'll explain the entire setup here in a second, and I'll click record, and I'll go to frame 50, and it will compute 50 frames, and I'll come back when that's finished. So that's finished. I'll click on stop, and we can see the entire process took almost 40 seconds, and we can see that the four largest contributors to the computing time were these four nodes here. Pop Solver itself, you can dive inside and adjust stuff. Like, for example, I can see that the largest amount of time took this one here, which is kill dead endpoints. Of course, I think this is more advanced, but if you understand solvers, in some scenarios, some of the parts of the solver are not useful, or are there just to, let's say, fix some errors, and they might be resource intensive. But I can see that I have 3 pop forces here. And the more pop forces you add, you'll each time add around 10 seconds of, or you're adding 10 seconds of computation in a timeline of 50 frames, which is of course not useful, because if I have 5 different pop forces, which I'm just adding some noise, I most likely don't need 5 different pop forces. So what I'll do here, we can see that the main one is this one. So I think this one's adding or contributing with the largest amount of amplitude, and these ones here are much smaller. So what I would do in this situation is either remove both of them, which will effectively shorten the computation time by 20 seconds, or I can only use two of them and adjust the settings. So in this case, I showed all these POP4. So keep in mind, if you're adding more and more nodes in your DOP networks, it will increase the computing time significantly, especially POP forces in this case. So that's why you can use the POP monitor if adding a certain node is worth the computing time. So yeah, I hope you learned something new, and I'll see you again. Bye.